Welcome back. We have a new lesson on evaluating trig functions that are not on the unit circle. So we know that sine and cosine are represented by the y and the x coordinates on the unit circle. Now we're going to have values that aren't those exactly. So they're not going to be our 30, 45, and 60 angles that we've been dealing with recently. So we have just a quick little review. Remember, sine of theta, and theta is always going to be that angle right at the origin. And if we're in quadrant 1, as our little diagram is drawn, we have to go to the right, we have to travel up, and then we come back and draw our hypotenuse, which is the radius of the circle, which has a value of 1. So again, sine of theta is going to be the opposite over the hypotenuse, y over r, or y over 1, which just gives us y. Its reciprocal is cosecant. So cosecant of theta is going to be the hypotenuse over the opposite side. R over y, 1 over y is its value, or you can just remember the reciprocal of y, or take that y value and just flip it. That's what reciprocal means. Okay, the next one we have is cosine of theta. That's the adjacent over hypotenuse, x over r, or just x over 1 equaling x. So cosine is x. Its reciprocal is secant, hypotenuse over adjacent. And the reciprocal of x would be 1 over x, because our radius is 1 for the unit circle. Remember, we can just flip the value of x. And then the last two that we have are tangent, the opposite over the adjacent. That's sine over cosine, or y over x, and cotangent, adjacent over opposite, which is cosine divided by sine, or the x over the y. So another quick reminder, we have that little silly phrase to help us remember which trig functions are positive in their given angles. So all trig ratios are positive in quadrant 1. Sine and its reciprocal cosecant are positive in quadrant 2. And that's because we have the x value is negative and the y value is what's positive, only the y. So that's why sine and its reciprocal. In quadrant 3, to get there, we have a negative x and a negative y, so both x and y are negative, therefore tangent, negative y divided by negative x, will give us a positive value, and its reciprocal. And then in quadrant 4, we have an ordered pair x negative y. So the x is what's positive, which is why cosine and its reciprocal secant are positive in that particular quadrant. So remember, it's all students take calculus. Now the next little images I'm going to show are how to draw a triangle in each of the quadrants. Quadrant 1, from the origin we go to the right, up, and back. In quadrant 2, we go to the left, up, and then back down to the origin. In quadrant 3, we go to the left, down, and then back up to the origin to make our hypotenuse. And last but not least, in quadrant 4, we go to the right, down, and then back up to create that angle at the origin. So you'll notice you can kind of remind yourself. Some people think that that looks kind of like a butterfly or maybe a bow tie, whatever helps you remember so that you get your triangles drawn in the correct quadrants. All right, let's practice some. Here's our first example. The terminal side of an angle alpha goes through the point -3, 4. Find the values of the trig ratios of alpha. Remember, alpha is just another angle. It's just like x, or it's like theta, okay? Just another way to do it. So to get to that particular point, a point where that angle lands, I have to travel to the left 3, and then I have to travel up 4. So that's going to give me a right triangle in quadrant 2. Now, in order to get the length of the hypotenuse, we are either going to use Pythagorean theorem, as shown below, or if you remember, that is a 3, 4, 5 triangle. That's one of those Pythagorean triples. So now to get sine of alpha, we want the opposite side over hypotenuse, so that would be 4 over 5. Its reciprocal cosecant, hypotenuse over opposite, 5 over 4. Cosine should be the adjacent over hypotenuse, or -3 over 5. Its reciprocal, secant, is -5 over 3. And again, that negative really goes with the 3 that's in the denominator, but you can just make the whole fraction negative. And last but not least, we need tangent. that ratio will be the opposite over adjacent, or 4 over -3, -4/3. Its reciprocal cotangent is the adjacent over the opposite, which will give us -3/4. Great job with our first example. Okay, in example 2, we have cosine of alpha is -3/5, and alpha lies in quadrant 2. Again, find the values of the trig ratios of alpha. Now you'll notice I have each of my trig ratios listed, and they already gave me cosine. I'm going to go ahead and write it. You can also, before you do anything else, determine the reciprocal. Secant would be -5/3. Okay, so let's go ahead and sketch, see what everything looks like. And to get cosine into quadrant 2, I'm going to have to sketch to the left, label that as -3, and then go up. We'll label that as y, and then back down to the hypotenuse at the origin, and we'll give that a value of 5. Okay, so just double check. Adjacent over hypotenuse is -3/5. We are good to go. Again, at this point, you may use either Pythagorean theorem, or remember, this is another Pythagorean triple. It's the same one we just did. So either way, whichever helps you remember, so that you can solve for the y value or the opposite side of alpha, angle alpha, so that you can get all 3 sides of the triangle to write the ratios. So again, we were given cosine of alpha is -3/5. Its reciprocal is -5/3. Don't do any work, you already know that one. Then we solved for y so that we could get the other trig ratios. Sine is opposite over hypotenuse, or 4/5. Its reciprocal cosecant is hypotenuse over opposite, 5/4. Tangent of alpha is the opposite over hypotenuse, opposite over adjacent. I said that wrong. Opposite over adjacent, which is -4/3. And cotangent of alpha will be -3/4, the adjacent over the opposite. All right, we're almost done. Example 3. Given tangent of b, or beta, equals 2/3, and sine of beta is less than 0. Okay, so beta is another representation for an angle, just like x, theta, alpha. So same kind of thing. Again, find all the trig ratio values of angle b or angle beta. They gave me tangent of beta to equal 2/3, so I go ahead and list that. You can go ahead and do its reciprocal cotangent. That would be 3/2. Okay, we'll come back to it. How are we going to sketch this one? Where does it go? So tangent, where is it positive? Okay, in quadrant 1, y over x is positive, and again in quadrant 3, where -y over -x is positive. Okay, sine of beta is less than 0. That means, where is sine negative? So sine is my y values. Sine is negative in quadrants 3 and 4. Now the overlap of tangent of beta and sine of beta, for this example, occur in quadrant 3. That's where we will sketch our triangle and determine the missing side length. So we're going to have our triangle going to the left and down, and we know that the opposite side, or the y value, is going to be 2. The adjacent is going to be 3. There's our hypotenuse, continuing out our triangle. And don't forget, yes, tangent is positive in this quadrant, but that's because both the x and the y values are negative. Okay, be real careful of that. That's a silly goof that people make on occasion. So watch that. All right, we do need to use Pythagorean theorem. This is not a triple, so that we can solve for the length of the hypotenuse. Remember, hypotenuse value is always positive. It's a distance from the origin to the edge of the circle, or that distance, between the points if you're just doing a right triangle anywhere. So that's always going to be a positive value. Okay, so again, we've got tangent of theta is 2/3. Its reciprocal cotangent is going to be 3/2. Then we can do sine of theta. That will be opposite over hypotenuse, -2 over square root of 13. You need to rationalize. Multiply by square root 13 in numerator and denominator. So I'll get -2 root 13 divided by 13. Before we rationalize, you can take the value of sine and write its reciprocal to give us cosecant. So cosecant will be negative square root 13 over 2. Again, I'm not doing the rationalizing a second time. I'm not doing that multiple times. I'm just taking the value of sine and writing its reciprocal. Okay, so cosine of, that should say beta, excuse me guys. So cosine of beta is negative 3 over the square root of 13. Go ahead now and write the reciprocal for secant. Okay, we'll come back and check it. And then when we rationalize for cosine, we will get negative 3 square root 13 divided by 13. All right, and our secant value is the reciprocal of cosine, which originally is negative 3 divided by the square root of 13. So that would be negative square root 13 over 3. And I do have a little typo there, so let's fix this guy real quick and make that guy a 3. There we go. Sorry for that goof. Okay. All right, let's scooch on. We've got one more to get to. Number 4. You're given that cosecant of beta is 13 over 12, where pi over 2 is less than beta, which is less than pi. Again, we're finding our trig ratios of that entire angle. I know one of them. I know cosecant. Cosecant of beta is 13 over 12. You can go ahead and write the reciprocal and figure out what sine is. That's one way to do it. Okay, so let's think about all the stuff that we need to know. So cosecant is the hypotenuse over the opposite. Remember, that's the reciprocal of sine. So I have the opposite side and the hypotenuse. Okay, gotcha. All right, now we got to figure out pi over 2 less than beta less than pi. That's giving us angle values. Remember, pi over 2 is 90 degrees and pi is 180. So that's telling us that the angle beta is between 90 and 180 degrees, which puts us in quadrant 2. Great. All right, now we are going to sketch the angle in quadrant 2 and determine the length of the missing side. So we're going to go to the left, we're going to go up, and then we're going to connect from the origin back to that point. There's our triangle. And again, for cosecant, we know that the hypotenuse is 13. We know the opposite side of the angle is 12. And you can either use Pythagorean theorem to determine the value of x, or you can, again, remember that that's one of the Pythagorean triples. That is a 5, 12, 13. So the value of x is 5, but don't forget, we are in quadrant 2, so we've got to make it a negative 5 because we're going to the left from the origin. All right, let's finish up. Again, given cosecant of beta is 13 over 12, therefore its reciprocal sine would be 12 over 13. You could have already done that one. Cosine is going to be adjacent over hypotenuse, so that would be negative 5 over 13. Its reciprocal secant will be the hypotenuse over the adjacent, negative 13 over 5. Tangent is the opposite over the adjacent, so negative 12 fifths. And cotangent is the adjacent over the opposite, so that would be negative 5 twelfths. Great job, guys. Proud of you for sticking with me through this. And if you have any questions, come find me in class.